If you're struggling at all with doing the proofs, that's okay. It's a common experience all beginning students in logic do. And there's two ways of struggling with proofs. One way is from the creative point of view, how do I start from scratch and come up with all of these steps on my own? Now that's very difficult, but almost as difficult is going and looking at the solutions and realizing that even when you see the solution fully written out in front of you, you're not really sure exactly how to parse everything that's going on in the solution. So in this video, what I'd like to do is give you some tips on how to work through the solutions to come to understand the proofs. That's the first step to being able to do proofs all on your own. And the examples that we've been doing in the homework are very complicated. That's by design. We want to throw you into the deep end and give you a sense of how to go about these more difficult problems. When the final exam rolls along, we'll give you some that are a little bit simpler than that. The first step when looking at proofs for arguments with premises is to look at what logical connectives are contained in the premise and start thinking about or strategizing about how you could use the elimination rules for those logical connectives. Let's look at a really simple example here in exercise 4. This is from Gamut. We have a premise with the connective of conjunction. So we want to start thinking about how we can use the elimination of conjunction rule. And the elimination of conjunction rule is really simple. Since we know we want to get to R and P, we know we can put those together with an introduction of conjunction rule. So all we need to do is deploy our elimination of conjunction rule to get R and P all by themselves. Now, exercise 9 is a proof in which we have no premises. That is, it's proving a theorem of logic, a tautology, something that's always true, no matter what. You don't need any assumptions to get you there. So notice we do have assumptions on proofs that have no premises, but all of them are discharged. That is to say, all of them are ultimately inside the boxes here. The first thing to do when trying to reverse engineer a proof is to look at all of the assumptions. So look over here and find the assumptions. For each assumption, try to figure out why they assumed that particular thing. In order to discern the purpose of an assumption, go to the line where that assumption is discharged and see what they get out of the assumption. So in other words, go to the line where let's look at like line 2 here. This is an assumption and it's tracks all the way down till line 8 and then the box is closed off for assumption 2 here. So line 9 tells us what we got out of the assumption on line 2. Namely, we got not P through our introduction of the negation. So that tells you, look, the purpose of assuming not P was to get a double negated P. Now, why would you want to get a double negated P? Well, that's where the power of the double negation rule comes in. Anytime you have a double negated proposition, you can just drop off the double negation and get the proposition itself. So we can see ultimately what we got out of the double negated P was P itself. Okay, so we see why we assumed line 2. Let's look at this third assumption. Why assume P? Well, the process is go to the line where the assumption is withdrawn or discharged and see what's written underneath that. So the point of line 3 was to get to line 6, which is an arrow statement. So we're assuming P to get P as the antecedent of an arrow statement. Why would we want to do that? Well, look at this. This is the same arrow statement up here in our initial assumption. So what we've derived in lines 3 through 6 is the antecedent of line 1. That will allow us to use arrow elimination to get P, which will draw the contradiction out for line 2. And that will allow us to end up discharging line 2. So when working with these nested assumptions, you have to recognize how they interact. The way to do this is to look at each assumption in turn and try to understand why that assumption was being used. To understand why an assumption was being used, go to the line where the assumption has been discharged, see what you get out of it, and then see what that buys you in the other lines of the proof. Let's look at another example. Here's exercise 9C. What we're trying to prove here, again without premises, is this big arrow statement down here. So we know we're going to, as a first step, assume the antecedent, and that's just what's been done here. And the rest of the proof is going to be spent showing that assuming this leads to P and not Q. So everything else from lines 2 to 16 is going to be busy about showing P and not Q. So how do we show P and not Q? Well, it's a conjunction. So we need to get each of the conjuncts on a separate line by themselves. Once we have P on a separate line and Q on a separate line, not Q on a separate line, we can then conjoin them, and that will be the final step of the proof on line 16. So again, that's the first step of reverse engineering. Now we need to go and look at the assumptions. Why do they make each assumption? The first assumption is made, as we already addressed, because what we're trying to prove is an arrow statement. And in order to use arrow introduction, we always know that we're going to need to just assume the antecedent. So why assume not P here on line 2? Well, let's follow the yellow brick road to where it's withdrawn or discharged. We see that what we get is a double negated P with introduction of negation. Now, why would we want a double negated P? Well, because we can then use, so that tells you, the reason we assumed not P to begin with is because we were going after P, and we knew that a good way to get to P would be to get to a double negated P and then use the double negation rule. So having assumed not P, how do we derive a double negation? Well, we need to use our introduction of negation rule, and that means we need to get a falsum. That is, we need to show a contradiction. Let's then go to the third assumption. Why is this being assumed? Let's track it to where it's discharged. We see it's discharged here on line 6 for P arrows Q, arrow introduction. So we're assuming this P in order to get P arrows Q. Why? Well, that will allow us to derive the falsum we ultimately wanted from the assumption on line 2. P arrows Q is the direct contrary of this negated P arrows Q on line 1. So that allows us to derive a falsum. We've shown that if we assume P, we ultimately get led to a falsum. So then we get the not P that we already discussed. So we've got our P, and that's the first element of what we needed for the consequent. Now we have two more assumptions. These are going to be in view of getting not Q. So we're going to start by assuming Q. Why do we assume Q? Well, let's follow the yellow brick road to the discharge. What we get is not Q with the introduction of the negation. So we know that the reason for assuming Q was ultimately to get to not Q. Let's look at the assumption on line 11 here. P, follow to where it's discharged. What we get is an introduction of the arrow statement. So again, we were using introduction of the arrow statement to show that if we assume Q, we'll ultimately get led to falsum. That is, we'll have P arrows Q and not P arrows Q on line 1. That gives us this falsum, gives us the introduction of negation. We now have P in only the first box, and we have not Q in only the first box. That allows us to use our conjunction introduction to get P and not Q. We have now officially shown that assuming negated P arrows Q leads to P and not Q. So we have shown that what we wanted, line 17, our ultimate conclusion using arrow introduction, discharged all of the assumptions, and we're done. So line 3 has P in it, and if that's ultimately what we were trying to get, since P is the consequent of the conclusion, why weren't we able to just stop at line 3? Well, line 3 is an assumption, and so it's inside a box, which means we can't use it until the assumption has been discharged. So why just assume P? Well, you know that you're going to be able to get a contradiction with not P. So the whole point of assuming line 3 here was to get this falsum here using the elimination of negation rule. That then introduces us to the power of EFSQ. Since EFSQ allows us to derive any arbitrary proposition from a falsum, we can then get Q, since that's what we wanted. Question is, why did we want Q to begin with?